Hi everyone. So welcome to my another video of day 3 of daily Leetcode problem solving. So now today we are going to solve this problem, that is minimum number of operation to make all the array elements equal to 1, right? Right. So let's go through the problem once. So given that you are given an index 0 index nums, that is an array, and it only contains the positive integers, right? So basically like this, 1 2 3 and so on. So now you can what you can do the following on the array. Any number of times we can do this operation. We will select an index, for example this, and such that it should be between 1 to n minus 1. For example, if this is 4 and 5, we should select an I from here, right, n minus 1, and replace either of the num1 and n plus 1 num of I. If we are selecting this, we can replace either this or this. If we are selecting this, we can replace either this or this. That's why it is taking till here, not till here, not till the end. So we have to replace either this or this with the GCD value, either I or I plus 1 with the GCD value, right? So, and we have to return the minimum number of operation to make all the elements of num2 equal to 1. So we have to return the minimum number of operation that will require to make all the elements to 1, right? Basically हमें 1 बनाना है, right? So what is GCD? GCD is the greatest common divisor, we say, of any two numbers. So what is greatest two dividers? The maximum number, the greatest number which divides both the numbers. For example, which is a divisor of both the numbers. For example, it is 12 or 15. So which is the greatest number which divides both? That is 3. So 3 4 ja, it's 3 4 into 12 and 3 5 into 15, right? So let's like this, if it is 14 and 15, so the greatest divisor of this will be 1, that makes it 14 and 15, right? So this is GCD. Let's move forward um, with an example. Let's take this example. Let's take this example, right? So how we will solve this problem? So the first thought in our mind is, first we should know this thing first, like GCD of any number with 1, right? Any number with 1, this is a property we can say, will be 1, because 1 is the smallest number, for smallest positive number, and a, so 1 is the only number which divides both, right, which is a divisor of both. So this is a property. So from this property we can say, if any number, like if any device, if we get 1 in this array, then others will become 1. For example, if we get 1 here, then we can take this pair, and we can take this pair, and we can, and when it will become 1, then we can take this pair. So right, if we got 1 at any position, then we can make all of the array 1. So is it possible? If we are not able to make any one in the array, then we are not able to convert the array into ones, then to it is not possible to convert the array, right? So let's do further, like we can check one by one, like, is this make 1? Is this make the GCD 1? No, the GCD is 2, right? GCD is 2 for this. Let's check this. Is this make 1? No. Is GCD is 3. Greatest common divisor is 3. Will this make 1? Yes. 3 and 4 GCD is 1. So we got 1. So let's replace either 3 or 4. Let's replace 4. Right. Now we got 1. So we will take 3 or 1. It will make 3 as 1 because of this property. We will take 6 or 1. It will make 6 1. We will make 2 2 1 by choosing 1 or 2. So now what will be the count? So we have taken 3 4 at once. Then we take 1 or 3, 6 or 1, and 2 or 1. So total count is 4, right? So what we analyzed, if we got 1 in the array, then the uh, minimum operation required to convert the array is n minus 1. So first, to we what we should do is, uh, let's take another example. Right, here we can say, 210 is 2, GCD is 2, 10 6 GCD is 2, and 6 4 GCD is around 2, right? So we did not get any value to 1, so like we are not able to make it 1, so that's why it become minus 1, because if we are not getting 1 in the array by any of the GCD, then we are not able to convert it to minus 1. That's why it's minus 1, right? So how we will proceed with this? So let's say we need 1. How many ones in the array? Because those are the values which are already at the ones value. So we can say we will count. We can say 2 1 4 1 5. So we will count how many values are at once. For example, this and this. So two values are at once already. So we need to convert 2, 4, and 5. So we need to pair 2 with someone, and 4 with someone, and 5 with someone. So we required three operations. So this is basically n, that is number length of the array, minus number of ones in the array, that is 2. Right. So this will be our answer. So this is how, if any one is present in the array, then this is the answer. If there is no one present in the array, so we will figure out, is there any pair which is making one in the array. If it is possible, for example 3 or 4 makes one, so then we can make the array as, make the answer as n minus 1, because n, only n, because one operation is required to convert one value to one, and the rest values will converted with the help of that one, so that then it will make the operations, and an operation is required to convert all the numbers. Now there is one case, if none of the pair gives me one. So what we can do, we can check either three values or four values make the value one. So maybe the minimum, we can say, subarray. So minimum length subarray that makes the GCD one will help us in that case. For example, if for example this, we need to find 3 6 and 2 1, right? Now, if we look into the pair, for example, 3 and 6, it will gives us 3, right? 6 and 2, it will gives us 2, and let's make it 4. Right? So this will gives us 2, right? But if we replace 3 or 6 with the number 3, if we replace with their GCD 3, that is one operation, and 3 and 2 will make 1, right? So we got one, right? So with this one we can change, we can like replace all the others variable. So as in the question we can see that the number of length is 50, so we can go for the n square approach because the n is very less. So we can find the minimum length that make the GCD 1. So when we found 1 in the array, so that can make, that is the minimum operation required. So to make 1, what is the minimum length required? So that is the length of the sub array, right? So that is the minimum length, right? Minimum length of the sub array. And after that there is one that we got, and the remaining one is n minus 1. So that is minimum length minus 1, because that is the array length minus 1, because we are making this much operation is required to make the array to make the one value to one value 1. And after that we will convert rest of the uh, uh, values, so that is n minus 1. So this will become a minimum, this will become minimum, plus n minus 2, right? This will become the answer. So yeah, so these are the three cases. Let's go to the code. So let's code it once. So we required a function first of all that gives us the GCD. So how GCD function is written? Uh, that is like this. We give him the two value. So it's just like we GCD function is like we gives a, we gives the b here, right? And here a modulo b. And if the a, if the b is 0, we will just return a. So this is the basic GCD function, basic GCD function, right? Now we will move forward. We will first, well, our first step will be take the array length, right? And we will also count the ones. So let's count the ones. So counting one, if x, not x, if this is one, then not this, like this, then nums sorry, one count plus plus, right? So if we are making it once, we are just counting how many ones are there in the array. If we found any one in any value having one, so we will just return that is n minus 1 count, which I have shown here, right? So that is this n minus 2, like this. How many numbers are of ones are there, we will just return it. So after that we will move forward. So what we will do, let's say our minimum length will be 1, right? No, sorry, n plus 1. Let's say we are taking a variable, and we have leverage to go through n square. So we will go, let's say here GCD will be now sky, and we will go forward. We will calculate the GCD of G and num sky. This should be I plus 1, right? If the GCD is 1, what we will do, If the GCD is 1, we will take the minimum length to minimum, that is will be minimum length, and that is j minus I plus 1, and we will break it, not return it, right? So if here, if the minimum length agar n plus 1 ही थी, if it does not change, that means there is no subarray that contains 1, so we will return -1. Otherwise we will what return minimum length plus n minus 2, as we demonstrated with this formula, right? So this will be our answer. So let's run it first. So there is one miss, we can say. Let me check it out. What is the problem? So I think all things are good. Just this should be J, because we are demonstrating J. Yeah. So let's submit it once. Great. So now, so we have analyzed the problem, and we can demonstrate by a dry run. For example, let's dry run with this. So we will first counting if there n is 1. There is no 1, so we will move forward, right? So here we can see like 2634. So we will move forward with 2626. No, 263. Yes, 24, 2, 2634. So like we are going forward with all the sub arrays and finding the minimum GCD. If we found the GCD one and with the minimum length, then we will just apply the formula minimum length plus 2 minus plus n minus 2. That gives our answer, and we have done the analysis for this here. So yeah, so thank you for watching. Uh, Please subscribe and press the bell icon for more updates. Thank you.